Hi, I'm Paul from Test Data Services, and I'm going to go through today some graphs that I've produced with RStudio based on some Gatling output, which I think you might find interesting. So when we run a Gatling test, we often get some very rudimentary charts and statistics, which are useful, but you get a lot of raw data. Now, if I feed that raw data into a package called RStudio, which is open source, I can then use that to produce a whole lot of graphs. This video is going to show us what we can get. And if I get positive feedback from the video, like if there's a lot of interest in how I generate the charts, I'll go into detail on them. But this is just a bit of an example, sort of to show you what might be possible, or what is possible. So this graph here from a test is showing us a particular transaction. Now, I'm not very good at RStudio yet, so I haven't figured out how to do a lot of things I'd like to be able to do, like having axes on both sides, for example. But in this graph, I've got a black line and a green line for a single transaction. And where's my mouse? The black line is showing us the workload in terms of transactions per hour. And the green line is showing us response time as the test progressed. Now this transaction in this test went for about 35 minutes. And we can see we've had a pretty big spike just here, which affected the transaction throughput as well. And we've got these fairly regular little blips that not exactly regular. There's not one here that we would expect. There's not one here, but it looks like there's a pattern here, right? So that's quite useful. Now, when you look at the raw data from Gatling out of the box, you won't even see this. It will just be hidden in the noise, but isolating it out is pretty useful. Also, it's nice to isolate out the ramp up, and we can see a slight fall off in throughput as the test progresses as well. Now, this RStudio script, which I'll give you a quick introduction to, generates all of these graphs in one go and sticks it into a directory wherever I want that to be. I'm just going to step through all of the graphs. So I've got a whole lot of scatter plots. Now, scatter plots are quite useful because it shows us how much variation that we've got in response times. So we can see from this, we've got a very strong trend here. Now, the way I've done these scatter plots is I've made each result a 10% see-through, or 90% see-through little circle. And if I've got overlapping circles, it makes it darker. So if I have 10 circles that all overlap, that overlapping spot will be quite dark red. And that's what we can see here. So the advantage of this is we see the odd outliers up here. And we also see these little vertical lines, which happen to line up with those spikes that we saw. But we can see it visually in a different way. We can also see that we don't seem to have just one response time. We've got a pretty fat tail, which is interesting. Let's just go through each of the others. The login, very good response time, very few slow responses for login. For purchase, we have these spikes here for purchases as well. If we were to look at the average, like the Gatling output would just probably show us one line down here, but obviously that's not right. These spikes don't have enough transactions as a percentage to cause it to show up. But if we look at it with a scatter, we can see these. Homepage, pretty solid performance with the odd slow response. And then logout, likewise, pretty good performance with a slight slow response. Now I'm going to look at response time distribution. Now this is quite nice because it shows us, in this case, a scale from 0 to 10 seconds in milliseconds and a relative frequency on the left. It shows us that our most popular transactions, the mode is just over a second, maybe 1.2 seconds. And we can see that it's not quite a normal distribution. It's a skewed distribution. It's positively skewed. But we have a few patterns over here, a few like bumps in the graph over here, which is interesting. So what we want to see in a well-behaved system is a really tight graph here. And we want it to be pretty close to normal. Let's look at purchase. So purchase, that's a much better main response, but we can still see these odd responses here all the way out to about 4 seconds. Let's look at login. That's pretty good. That's not exactly normal, but it's as close as you're going to get when you have a fast responding system. So that's great. And let's look at logout. Now, the other nice thing is that when we generate this data from, say, RStudio, and we output it as files directly, we can then just use Windows Preview, which is quite nice, which is all I'm doing at the moment. Okay, so this is response time distributions. Let's now look at with load, which is that first graph I showed you. And we can see this is the search performance. Let's look at purchase. Purchase, we've also got this fairly frequent blips. Let's look at login. And we can see hardly any performance issues with login. We can see this one blip here. Let's look at the home screen. And we've got the odd spike, but really nothing to write home about. And then log out. Now let's look at concurrency. Now I really like concurrency because concurrency often gives you a clue as to where your slow response time is actually occurring. If it's inside a function and you have a whole lot of those functions running and they are blocking on something like a lock or some event, then you will often see a spike in concurrency. Now, if you recall, in the response time chart, we saw this same pattern in response times, but we didn't always see it. But in the concurrency view, we always see this regular, actually we didn't quite see it there, but we almost always see a regular a blip for concurrency. That tends to tell us that the reason for that spike in response time is to do with what's going on in the actual transaction. It's just another view and it's quite helpful. Let's imagine that this problem that's causing these spikes in concurrency and response time was resolved, then we'll see a much flatter line here. Let's look at login, and login is so flat that it's not a very useful graph. Purchase, yep, we can see that same blip in concurrency for purchases. Home, logout, not very useful. Not all the graphs are useful. And then we've got all. All is a combined concurrency, so we can actually see what's happening across the whole system. Now I'll show you RStudio. Let's just drag it across here. So RStudio's got 4 little areas. This is the script I happen to be running. This is the console. Let me see what's going on. This is an output area. Now actually in here, which I haven't produced an automatic graph for this. I mean, some technical difficulties doing that, but we can see a chart here, which you can export. You can zoom. Let's have a look at zoom. Oh, it doesn't really zoom very much, but we can export as a web page, or we can copy to clipboard or save as an image. So we can do that, and when we do, we will see this nice chart, which has got the transaction names in here, and I've got this complete statistics for a test. Tells us when the test started, and we've got the count of transactions, what the average response time is in milliseconds, standard deviation, 50th, 90th, 95th, 97th percentile, and the number of errors in this period. There was a previous graph, which is generated by the same script, and it's actually looking at the peak 20 minutes of the test from the 10th minute. And it tells us the hourly rate rather than the count. So this chart tells us the actual numbers, and this chart tells us the hourly rate. And it tells us the number of errors that occurred in this 20-minute interval. So they are some of the nice things that we can have. Now, we don't get this out of Gatling, and I think it's pretty useful. Let's have a look now at what this script looks like. So I've got here, I've specified what where the actual data file is. I've got a few other values here. I say I want my granularity for some of my graphs to be 3 seconds. I want the start time for my peak consideration to be 10 minutes and the actual duration of the consideration to be 20. I import the numbers. Now, one of the problems with RStudio, and look, someone else might tell me how to do this, is that the timestamps being milliseconds have a lot of precision, and importing those numbers directly doesn't really work. We lose some of the precision when we do that. So I'm doing some little cheats in here to achieve that. I've got some script here that generates a table of results. So I'm using the tidyverse for this. And for example, I might do this transaction here. Transactions equals unique results TX name. So if I was to highlight that and hit Control Enter, it will actually run it down here in the console. And then if I say transactions and hit Enter, it'll show us what those transactions are. And if I was to run this bit of code, well, I'll show it to you first. Summary for period equals results, which is all of the results that we'd imported. And we're doing this piping into a range which sorts, and we're filtering out the start and the end times. We're grouping by transaction, and then we're summarizing. So if I was to just output this, we'll see that we've got this little table called a tibble, and it's got this data in it. And then I can go from a tibble, I can actually generate a table from that, which makes it look neat, and that's using the GT package in this case. To give you an example of some of the plotting, I basically, in this case, I'm plotting the response time graph, and I've got some calculations here to work out what the latency mean is, what the latency standard deviation is. I use that in some of the annotations on the graph. And basically, the real thing here is I'm doing a plot which is equal to all of my results. I'm filtering it by a transaction name that I'm considering, because I'm doing the one transaction at a time in this case, into ggplot, which is part of the tidyverse. And it then puts some titles on here. So, for example, if I was to just copy and paste this down here and run it, and then plot, right? If I was to just type in plot, it will actually show me a plot. And all of the values when I'm assigning something are just data structures, and then you can plot a data structure. But what I'm doing, instead of relying on this plot in here, I'm actually doing ggsave to a file name, and the file name is specified according to the run details, and so on. So I've got quite a few little charts in here to do calculations of concurrency and all sorts of interesting things. So if you're interested, let me know. I'm a beginner when it comes to RStudio, but despite me being a beginner, I can still generate some pretty cool graphs, which I think are pretty cool, especially graphs like this and concurrency. I hope you found this interesting. Let me know in the comments if you'd like me to dig in and show you how to use RStudio now that I've shown you what you can do with it. Oh, the other nice thing about RStudio is you can run it from the command line. So it's easy to incorporate into any CI/CD pipeline, and you can customize it for a very narrow set of automated tests where you know the parameters. I like, if I'm running a whole lot of tests and I want to compare analysis from one run to the next, I want all my scales to be aligned so I can visually see any differences. I'd also like to be able to plot on a single graph comparisons of the previous run to the current run. Now with RStudio, that's quite possible, which is really cool. So yeah, let me know what you think if you'd like me to dig in and show you how to use RStudio more, and I'll try and learn it more so I can show you better. Thanks. Have a good day.